Hi, everyone. Thanks for showing up for your learning. Here I am in the Google Meet where you can come ask your questions. In any case, I'm multitasking, and now we're talking about question type 5. When I give you the roots of a quadratic and one more point, you can find the equation of that quadratic. And here's how. Okay, find the equation of a quadratic with roots at x is equal to 5 and x is equal to minus 3 and passing through the point 6, 3. Okay, so let's copy those out carefully on a blank piece of paper, the top of my blank paper. So x is equal to 5 and x is equal to minus 3 were our roots. And it also goes through the point, what was it, 6, 3? Okay, 6, 3. Okay, visualize. Always visualize. Always. Broken record, Mr. Jennings. You say the same things over and over, and it's really annoying. Well, do it then. Do it and I'll stop repeating myself. Here's minus 3. Here's 5. Notice I'm not spending 8 hours making a diagram. And here is 6, 3. It's very fast to make this diagram. I can already see that my A value is going to be positive because it's a quadratic that opens upwards, and it looks shallow to me. Not like it doesn't have a lot of depth to its soul or baggage in its past. I mean, like it has an A value that's between 1 and 0. It's been shallowed out. It's been compressed. All right, that's 0.63. So I already have a prediction of what A value this parabola ought to have. I'm going to let f of x be this parabola, and I know there's some A value I don't know yet, multiplying it, but I got a pretty good idea of what range it's in. Multiplied by x minus the first root, multiplied by x minus the next root. Okay, let's simplify. F of x equals a multiplied by x minus 5 times x plus 3. So careful with the signs is he, Mr. Jennings. And then I know that f at 6 is equal to 3. That's this point right there. That if I input the value 6 for x, it will output the value 3 for y. I can use this knowledge to find a. So 3 is equal to a multiplied by 3 minus 5 times 3 plus 3. Okay, let's evaluate. 3 is equal to a multiplied by negative 2 multiplied by 9. I made a stupid error. So it's my visualization that saves me from telling you, here is the answer, everyone, because I knew that this was going to give me a negative value of a, but my visualization told me positive value of a. My stupid error was I substituted in the wrong value for x. It's not 3 that goes in there, it's 6. Because it's this point. X is 6 and y is 3. Learn from my mistakes, everyone. And how quickly I catch them. I catch them only because I had the visualization. 6 minus 5, 1. 6 plus 3, 9. Cool. Okay, so 3 is equal to 9a. This is 9 times 1 times a, so that's 9a. Divide both sides by 9. 1 over 3 is equal to a, because 3 over 9 is the same thing as 1 over 3. There, that was the only piece of missing information. Therefore, f of x, this function, is equal to 1/3 x minus 5 times x plus 3. And if some maniac asks you to express that in standard form, you just FOIL it. X times x, this is f of x, is equal to 1/3, put in brackets, x squared plus 3x minus 5x minus 15. Okay, simplify. F of x is equal to 1/3 x squared. This makes negative 2x. So I multiply that by 1/3. So that's negative 2 over 3x. And then multiply negative 15 by 1/3 minus 5. Okay, so that is the equation in standard form. This is the equation in factored form. To me, both are equally good. And you should be able to give me whichever one, or vertex form, but hey, I'm not a maniac. I'm not going to ask you to complete the square on that one. Actually, I might. Something I would think was fun. Okay, now, what about a word problem? A catapult throws a water balloon 100 meters from one end of a football field to another. It flies 1 meter over Max's head, and Max is fairly short. He's 150 centimeters tall, and he was standing 10 meters from the catapult. What do you think I'm going to tell you to do first? Visualize, draw a picture, okay? Here's my football field. It's 100 meters long. Here is the y-axis. It measures height. Okay, look familiar? This is the xy plane. Okay, here is my catapult here. Okay, that's a picture of a catapult, everyone. All right, and it launches it right from the edge here, wee, like this, 100 meters. I've been asked to find the highest point. Okay, I can predict that the highest point will happen at 50 meters because that happens to be the average of 0 meters and 100 meters. It's the middle point between those two things. And then we have this extra point here, Max. Max is not very tall. So we draw Max there. Hi, Max. And he is 150 centimeters tall. Let's convert that to meters. 1.5 meters. Okay. And it goes 1 meter over his head. That's this point up here. This is 10. So this is the point 10, 2.5. 2.5 meters in the air it is at 10 meters. Max, you should absolutely not be standing there. That's not safe. It's not cool what you're doing, okay? Have a mind for concussion safety, Max. So we would say that f of x, or no, let's not use f of x. Let's use height is a function of distance, okay? And this is now the distance axis, and this is the height axis. So the height of this balloon is a function of its distance, and that's equal to some value a that I know is negative and very, very shallow, multiplied by x minus the first root, multiplied by x minus the next root. Okay? Factored form of a parabola. Have I written that out in this one? F of x is equal to a multiplied by x minus one root multiplied by x minus the next root. Okay? This is the form we're using for all of these problem types. And then we solve for a. So the height at 10 meters, we know that's 2.5. So that's the point that we're going to use to solve for a. Okay, so 2.5 is equal to, we don't know a yet, multiplied by 10 minus 0, multiplied by 10 minus 100. Okay, aha, I see that's giving me negative 90. That's going to give me my negative a value. Yay! So this is equal to 900, but it's negative a is equal to 2.5. Okay, divide this by negative 900, both sides. Okay, and then reduce your fractions. Okay, this is, I'm going to show you how I would reduce this fraction in my head. I have different ways I would do it. I'll show you one. This is the same thing as 5 over negative 180. Okay, just multiply top and bottom by 2 to take away that ugly decimal. I think decimals are ugly. You think fractions are ugly. I'm better at math than you, so my opinion is more important than yours. Now, you can do it your own way. If you give me a decimal value for a here, that's going to work. You can convert on your calculator, but it's probably not going to be, well, maybe this is an exact value. I can't remember. Anyway, this is how many 5s are in 1800? Well, that's negative 1 over 360. Okay, that reduces to negative 1 over 360. So a is equal to negative 1 over 360. How do I know that? Divide 180 by 5. It has the common factor 5 in there, so you'll find that that's true. Okay, so now, therefore, h, height, which is a function of distance, is equal to negative 1 over 360 multiplied by x minus 100. Notice I didn't write x minus 0 there because that's just x. Okay, so here's my function. Now, we also knew from our visualization that we would have the vertex at 50. So rather than convert this to standard form and then complete the square to get it into vertex form, just so I can read the maximum height, just input 50. Okay, so let's find out. Height at 50 is equal to negative 1 over 360 multiplied by 50. That's x, multiplied by 50 minus 100. That's negative 50. Okay, so 50 times negative 50, that's negative 2,500. Negative 2,500 times negative 1 is equal to positive 2,500 over 360. The only factors they share in common is 10. So I can cancel that out, cancel that out. An exact value is 250 over 36, but a reasonable value, because in this case, we're an application question. Application question, things were given in meters and even centimeters. So I can convert this by saying 250 divided by 36 is about 6.94 repeating. Okay, so about almost 7 meters. This water balloon is almost 7 meters in the air. I hope that was helpful, everyone. Bye for now, and thank you for showing up for your learning. Any questions, send me an email.